Have you ever wondered what material can survive inside a jet engine, withstand the heat of a rocket launch, and still not melt, crack, or give up? A material so tough that ordinary steel simply fails where it succeeds. This metal doesn't rust easily, it doesn't weaken when red hot, and it's trusted in spacecraft, nuclear reactors, and deep-sea equipment. That metal is called Inconel. But what exactly is Inconel? And more importantly, how is something this strong actually made? Today, we're uncovering the surprisingly complex journey behind one of the world's toughest metals. Inconel isn't a single metal, it's a family of superalloys, metals designed to perform where normal materials fail. At its core, Inconel is mostly nickel, mixed with elements like chromium, iron, molybdenum, and niobium. Each version of Inconel uses a slightly different recipe depending on its job. What makes it special is how it behaves under stress. Most metals weaken when heated. Inconel does the opposite. It stays strong even at extreme temperatures. That's why it's used in jet turbines, rocket engines, gas turbines, and nuclear systems, places where failure simply isn't an option. The journey of Inconel begins far from airplanes and rockets. It starts with raw elements, nickel ore mined from the earth along with chromium and other metals. These are refined until they're extremely pure, because even tiny impurities can weaken the final alloy. Precision matters here. Inconel isn't mixed casually. Every element is measured carefully to control strength, corrosion resistance, and heat tolerance. Once the ingredients are ready, it's time for them to meet inside a furnace hotter than lava. The metals are melted together in vacuum induction furnaces or electric arc furnaces. Why vacuum? Because oxygen is the enemy. Even a small amount of air can damage the alloy's structure. Inside these sealed furnaces, temperatures soar above 1400 degrees Celsius. The metals melt, blend, and become a glowing liquid alloy, perfectly mixed at the atomic level. This molten Inconel is poured into molds or cast into large ingots, forming the solid foundation of the material. Once solid, Inconel is not easy to work with. It's incredibly strong, which also makes it difficult to cut, bend, or shape. Regular machining tools wear out quickly. To shape it, manufacturers use hot forging, rolling, or extrusion, often reheating the metal again and again to keep it workable. Inconel is commonly formed into sheets, bars, tubes, or complex engine components. This stage demands patience, specialized equipment, and extreme precision. Here's where Inconel truly becomes a superalloy. The shaped metal undergoes carefully controlled heat treatments. It's heated, held at specific temperatures, then cooled at precise rates. This process rearranges the metal's internal structure, creating tiny strengthening phases inside the alloy. The result? Inconel becomes resistant to heat, pressure, corrosion, and fatigue, all at once. It's this step that allows Inconel to survive years inside jet engines without losing strength. Before it's ever used, Inconel is tested relentlessly. It's checked for cracks, strength, heat resistance, and microscopic flaws. Only then is it approved for real-world use in aerospace, energy, chemical plants, and even space exploration. When failure is not an option, Inconel is often the answer. So the next time you see a jet roar across the sky or think about rockets leaving Earth, remember this. Behind that power is a metal forged through extreme heat, precision science, and careful engineering. Inconel. A reminder that even the strongest materials start as simple elements, shaped by human ingenuity. If you enjoyed uncovering the hidden story behind this incredible metal, like the video, share it, and subscribe to Simple Things, Surprising Histories for more everyday materials with extraordinary stories.